Alright, my name is Michael French, and like everyone else, I'll be talking about the golden ratio today. To start off, I have four rectangles. A study in the 1800s by a psychologist named Gustav Fechner found that he would have found rectangle number 3, which is made with golden proportions, the most aesthetically pleasing. Later on in the 20th century, a man by the name of Steve Jobs was founding the company Apple. And Steve Jobs is known for making things very aesthetic, so that's why we also have calligraphy in our text on our computers and stuff like that. When he was designing the Apple company logo, he used the spiral from the Fibonacci, or not Fibonacci, but the golden spiral, and so along the edge it is also noticeable. The ratio is founded on the base that A is to B as A plus B is to A. In mathematical terms, the precise exact measurement would be A would be a value of square root of 5 plus 1 all over 2, and B would be 1. This is important because it is naturally occurring. You can see it in various things like pine cones and seesaws. The spiral is actually generated through a golden rectangle, and as seen here, you have A to B, which is the B goes into C to D, and then that goes on to C and D. To make the spiral, you put each of the smaller rectangles inside the next larger one. And when you overlap these, you can overlap a spiral to where each older, smaller rectangle starts going into the bigger, new part of the larger rectangle. And so this generates the spiral which everyone has seen already. So one of the guys that is known for his work with this is a man named Phidias, who lived in 500 BCE, as seen here. He is known and credited as being one of 3 designers and architects for the Parthenon, and he used the golden proportion and golden ratio in so many of his works that the value of square root of 5 plus 1 over 2, or approximately 1.618, is known as phi in his honor. Skip ahead to around the 1100 and 1200 time frame. There is a man by the name of Leonardo Fibonacci, who is seen here. He wrote many conceptual math books and problems and published them. One of his problems that he published asked about if you put a pair of bunnies inside an enclosed garden and they were to live an entire year and reproduce once a month, and their babies would grow up in that 1 month time frame and also reproduce when they were of age, and these babies would be proportional and equal to male and female, then how many pairs of bunnies would he have at the end of 1 year? And to go about this, the first month, the 2 original bunnies will be maturing, so there will be no babies. The second month, they are both going to have babies and everything like that. And then the next month, the 3 bunnies are now mature and they're going to reproduce. And so then you get 2 pairs. And so this goes on for a full year. You generate the numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, and this goes all the way on for 12 months until you get to the number 144, which is the actual answer to the original question. When you put this into a rectangle, it looks very similar to the golden rectangle, but it indeed is not the actual golden rectangle. It is, if you did this until infinity, then it would get to the golden ratio. And they are both the golden spiral and the Fibonacci spiral are naturally occurring. They're part of a higher spiral category called equiangular spirals. And so you can see it in things like pine cones. This one actually has the Fibonacci ratio spiral going in opposite directions. And so going back to the history of this, or how it's been applied throughout history, the golden spiral is also talked about by a man named Luca Pacioli, who was a friend of Leonardo da Vinci. Pacioli asked Leonardo to help illustrate some of his books about the golden proportions. And it is said that Leonardo da Vinci was already interested in proportions, and this just helped further his interest in it. Some of the works that Leonardo da Vinci is known for developing with the golden ratio is the Mona Lisa, as seen here, and also the Last Supper, and also the Juryman. And so Leonardo liked that these were aesthetically pleasing, and he wanted to incorporate that as much as he could inside his artwork for this time period. Fast forward to around, I believe, the 1800 going on to 1900s. There was a man in Barcelona, Spain, named Antonio Gaudí. Gaudí was a naturalistic architect, and so he designed the facade of this building, La Sagrada Familia, to be made in golden proportions so that it was more aesthetically pleasing, and he also did the golden spiral in some of his staircases. Around the same time frame, a man by the name of Le Corbusier was developing a style of architecture called El Modular, which he incorporated in the United Nations building where every 10 floors you see a golden rectangle. So this, I hope you learned something in this presentation about history and application of the golden ratio. Thank you.
I thought you did a phenomenal job on briefing us on the, you were just very descriptive, which is really hard to do in those 20-second increments. And just, your voice was easy to follow, and it was easy to listen to all of that. So, good job.
Please.
I like how you mixed up with some of the topics brought up, like the Fibonacci and his bunnies, like really kept me focused because you were bringing up new different things. That was interesting.
You go.
Your timing was so precise on slide changes. It was incredible, which also made it way easier for me to follow because I could relate what was on the screen to what you're saying. I didn't, like, if you were to continue on an explanation from one slide into the next one, I would have to revert back to think what was on the next slide. So with you, with your timing, it was just incredible and way easier for me to follow.
Thank you.
Yeah, I think it's obvious you really knew your material, and you did not have to fall into reading about it. This isn't really this class, but of all three of the sections today, I've had several places where people have done a lot of reading from the cards. And all sorts of problems happen when you do that. If you're reading actually faster than you would normally speak, and your inflection changes, and you lose your eye contact with the audience, et cetera, et cetera. So it was apparent that you really knew your material, including the pronunciations of the things you had to pronounce there. The one criticism I have of your slides is you've got some pixelated slides where you've got, in an attempt to use the whole screen, you stretch things beyond their capacity to stretch. And there were actually things that you could recreate easily rather than taking it. So I think there were two of them at least like that, where there's just heavy pixelation. And that doesn't look professional to begin with. You have to do a Pecha, Kucha in a professional environment. But also, it's really a chance to enhance because you can then choose the colors and stuff like that. And can help you control the colors overall to make it look like a more integrated presentation. Anybody have some other observations?
Something that I would say that helped your presentation was all of the research you did, and there's a lot of evidence that you presented that made it sound like you knew what you were talking about instead of trying to like bull crap your way through the presentation. So I really appreciate the amount of information and research that you have included in your presentation.
Thank you.
Yeah, and I think also that you use some different images. You don't usually see Gaudi in one of these presentations because I've used this topic a number of times over the years, and yet it's fascinating there. And I mean, we'll always see the Parthenon, even though it doesn't perfectly fit this.
Right.
But you don't always see some of the ones that you chose there, and so I think that's good. Other questions or comments?
Good job.
Okay.